Next, we are going to look at sorting algorithms. And you have to know there are many sorting algorithms, and some of them work on certain types of inputs, some of them may not, and some of them are better than the others in some aspects, and some are advantages in certain cases, etc. Of course, we are not going to go into those details, but here I'm going to introduce you to the most basic sorting algorithms. And if you're interested, there are algorithms textbooks, and there is a vast amount of information online anyway, and you can check those. Um, the One of the most simplest sorting algorithms is the insertion sort algorithm. What happens here is that you actually uh, first make sure that the first positions are sorted, and then you do this by actually iterating backwards. So the pseudocode is given here. So it starts from 2 to n, because, well, you don't need to start from 1, because, well, you need something to compare to. So you start from j, I minus 1, down to 1. And if the two values here, the two consecutive values are in the wrong order, then you swap them, you exchange them. Otherwise, you don't touch them. And repeating this for the entire sequence gives you a sorted list. Let's see this on an example. Assume that we have a sequence consisting of only 5 values, and they are actually ordered in this 2, 5, 3, 1, 4 sequence. And we would like to actually order this in ascending order. So what you do is, well, if you just look at this subsequence, that by itself is going to be ordered. And then you take this next value and you insert it, as the name suggests, to the position among the in order portion of your sequence. So the first position, since it's by itself, it's just one value, it's assumed to be ordered. So this is the ordered portion, okay? And the next value, 5 in this example, is going to be inserted to the ordered portion in the correct position. So what you do is you compare it with the next value, and then here you see 5 and 3, when you compare them, they are in the wrong order, so you swap them. You put 3 before 5, so you are inserting 3 to the list of 2 and 5. Actually, when you look at this in this way, if you compare 5 to this only value here, it's in the correct position. So in the next iteration, this becomes the in place, or rather the sorted portion. And then you take the next value 3, and you would like to insert this value within this sorted portion so that its position is correct. So of course, when we look at it, we know that it has to go in here, in between 2 and 5. But how you do it is you just compare it one by one to these values by scanning it backwards. So you compare 3 and 5, you see that they're in the incorrect order, so you swap them. So 3 comes here, and then you compare these two, 2 and 3, but then you see that they are in the correct order, so you stop. You don't need to look even further, because you know that you are in the sorted portion. So what if even if you have something here, it will be even smaller, so you don't need to compare it to 3. And then 3 will become in its correct position within the sorted portion. And then you take the next element in your sequence, 1, and you would like to insert this in the sorted portion. So you compare it with 5, the order is incorrect, so you swap them. And then you compare this to 3, the order is incorrect, so you also swap them too. And then finally, you compare these two, and the order is still incorrect, so you swap them. And now you have reached the end of this list, well, or rather the start of this list, so you cannot go even further, which means the correct position within this sorted portion of 1 is this location. So it will be correct in the next iteration, and you will need to insert 4 in this sorted portion. To do that, what you do is you compare these two, and the order is incorrect, so you swap them. And then you compare these two, the order now is correct, so you are done. Everything is sorted now. Now, this sort of operation is called in place. In place in the sense that you modify your sequence in its current place. You don't need to use extra memory, except for maybe one location for the swap operation. You don't need to maybe replicate your sequence. You don't need to use any further memory positions. So this we call in-place sorting. So the algorithm does not require extra memory space. This is an important property of sorting algorithms. Some of them are in place, some of them are not, which means they might require a higher memory